When someone thinks of ice, it's definitely not something that can burn, correct? But instead, ice can catch on fire. It's possible through clathrate compounds. Hi, my name is Rebecca Lloyd. I'm going to be talking about the chemistry of methane hydrate compounds and how they can be used as a future fuel source. So methane hydrate compounds are categorized as clathrates, which occur when one material is nested within another. In this case, it's methane inside of water molecules. The water molecule is made up of 2 dodecahedral and 6 tetradecahedral water cages per unit. Inside, it contains a very, very high concentration of methane, such that if 1 meter cubed of the solid, when melted, produces 160 meters cubed of gaseous methane. Methane is considered a saturated hydrocarbon because it is only made up of carbon and hydrogen with single bonds. This allows it to be easily frozen around water because it doesn't chemically interact with the water molecules. The water freezes around it. Methane hydrates are formed similarly to how fossil fuels are formed, except deep below the ocean surface. Methane is still made from bacterial decomposition of plant and animal matter, but in this case, the methane hydrates need very high pressures and low temperatures to exist. In this case, this is why scientists thought that methane hydrates only existed in outer space because of the environment that space entails. Once scientists began looking for these deposits, they weren't disappointed. They found them in 2 main locations. One being the permafrost locations located next to the Arctic Circle, and then second were in oceanic locations. The oceanic locations occur at a subduction zone. A subduction zone is when 2 plates interact and one goes beneath the other. In this spot, it is easy to form them because of the high pressures that are formed, and it's low enough that it's low temperature. In the permafrost location, they aren't quite as deep as in the oceanic locations because of it just being very cold. And so the high temperatures allow the water to freeze. It is said that there's about 100,000 trillion to 300 million trillion cubic feet of methane that exists in these deposits, that we just need to access them in order to serve as a future fuel source. But the mining of methane hydrates is a difficult process. Here it is shown how a drill rig would go into a gas hydrate deposit and collect it. In part A, this would be incorrect because there's no cap, so the gas hydrate would escape to the surface. Here, in this aspect, it's a little bit better because there's a wellhead that covers the drill, so it won't escape quite as much. But since the mining occurs at approximately 1,600 feet, it's very deep and very hard to get the drill rig to be stable and exist in that aspect, as well as the sloping seafloor is also very difficult, so then also can't be stable, and it's very difficult to run pipeline. One of the other problems is that since methane can escape when it's melted and comes to a higher temperature, scientists are afraid that the influx of methane emissions will cause an increase in global warming. So will we be able to use this as a form of fuel in the near future? The short answer is yes, but unfortunately, since it is very difficult to determine a reason on how to actively get this from the ground, it might be a no. But there are scientists that think that if they use hot water in the drill pipe, then it will melt the water and then you'll be able to get the methane out very easily. Same with the CO2 example. This is the current way where you just get everything together and the methane can escape. So hopefully one day you see ice on fire and realize that it could possibly be methane, a methane hydrate compound, a fuel of the future. Thank you.